Let's learn about bonding. Bonding is a topic in chemistry paper 1. It's topic 2, chemistry paper 1. There are 3 types of bonds: covalent, ionic and metallic. In my explanation, I will be taking you through the atoms that these bonds take place between, what happens to the electrons, and a few examples. Okay. We'll start off with covalent. Covalent bonds happen between a metal that is a non-metal and another atom that is also a non-metal. So covalent bonds take place between 2 non-metals. What happens to the electrons? The electrons are shared between one atom and the other. Okay. An example would be water. Hydrogen is a non-metal, oxygen is a non-metal. Oxygen is in group 6. It has 6 electrons in its outermost shell. Hydrogen's in group 1 and there's 2 hydrogens. Hydrogen will share 1 electron each with oxygen. Now hydrogen's only got 1 shell with 1 electron. By sharing 1 with oxygen, oxygen shares 1 back. Hydrogen now has 2 electrons in its first shell. It only has 1 shell, it had 1 electron of its own and 1 shared with oxygen. Now hydrogen has formed a covalent bond. The same thing has happened over here with another hydrogen atom. What we must be careful of is when we draw the electron shell, the electrons that are shared are drawn in the overlap region. We will draw this as H2O. Okay. Another example, let's go with CH4, let's go with methane. So this is water. Let's go with CH4, which is methane. We'll start off with carbon. Carbon is 12-6 carbon, has 6 electrons, 2 in the first shell, 4 in the last shell. Carbon's in group 4. Carbon's in group 4. Okay? So we draw carbon with its 4 electrons in its outermost shell, and we draw the sharing of an electron, but with 4 hydrogens, giving us CH4. We will draw this like this. The stick diagram would be a carbon. Each of these straight lines represents a covalent bond. Last example, we're going to go with carbon dioxide. Carbon dioxide, slightly different. It actually shares 2 electrons each. Makes a double bond. We'll start off with the carbon in the middle. Carbon has its 4 electrons. Now, there are 2 oxygens. Now, oxygen's in group 6. Just needs to share 2 electrons for it to be stable. So this is what it does. Oxygen's here. 2 of its electrons will be shared, and the remaining 4 are left in the shell. There's oxygen. The dots represent oxygen. This is a dot and cross diagram. The 6 electrons for oxygen in overlap with the 2 crosses with carbon. Carbon has got now 4 of its own electrons, 2 shared from oxygen. That gives it 6. It would love to share another 2, and in fact that's what it does with another oxygen over here. Now because carbon is sharing 2 electrons with oxygen, making 2 covalent bonds on both sides, we draw it like this. Ionic bonding. Ionic bonding takes place between a non-metal and a metal. In this example, electrons are transferred from the metal to non-metal. So in covalent, the electrons are shared. In ionic, the electrons are transferred from the metal to the non-metal. An example of this will go with NaCl, which is sodium chloride. And sodium has 1 electron inside the outermost shell. Chlorine has 7 electrons inside the outermost shell. They react. This electron is transferred from the sodium, which is a metal, to the chlorine, which is the non-metal. Now, we're going from atoms to ions. When we draw ions, we represent ions with the square brackets around them and the charge outside. So, square brackets and charge. The charge, we can decide what the charge is by looking at whether the atom has gained or lost electrons. If the atom has lost electrons, like the sodium, it will get a positive charge. And we will put the sodium in square brackets to show that it is a sodium ion with a charge. The chlorine, the non-metal, has gained 1 electron. The chlorine has a minus charge. It is now an ion. We'll put square brackets to show that here. Okay. Another example is zinc chloride. Okay, zinc chloride. What happens with zinc? Zinc is the metal, and it will provide an electron to 2 chlorine atoms. Now the zinc has lost 2 electrons, each chlorine has gained an electron. So we say the zinc has become a 2+ ion with the square brackets, and we have 2 Cl- ions, giving us the formula ZnCl2. The last one for me to talk about is metallic bonding. This happens just between metals. And the electrons, we say, are delocalized, free to move. This is the fundamental, the outer electrons are free to move, we say they're delocalized. This is the fundamental reason why metals can conduct electricity.